This is Geometry Lesson 3.6, using logs in the mathematics of finance. So a whole bunch of formulas on here. Encourage you to follow along in your online book to see these. All right, if a principal P is invested at a fixed annual interest rate R, then the value after n years is P times 1 plus R to the n, where R is expressed as a decimal. So suppose Paul invests 400, so that's our principal, times 8%, 0.08, then we put the 1 in front, to the fifth power. Take out your calculator. Clear. 400 times 1.08 to the fifth, $587.73. Okay? Annual interest equation. All right. Suppose the principal P is there's different times. So K is how many times per year it's going to compound. So like if it's 12 months, then K is 12. There's your continuous interest equation down there as well. P times e to the RT. So let's try a couple of those. Just remember, if the timing changes, you're going to want to use that. That's the equation that we use the most. All right. So suppose same Paul, 400 bucks times 1 plus 0.08 divided by compounded monthly. So that means our month is going to be 12. Okay. Find the value of the investment after 5 years. Well, if it's going to go 12 times a year for 5 years, that means we take 12, which gives us 60. All right. So I would take 0.08 divided by 12. If you do that, it's almost easier just to leave parentheses and not round. So I would go 400 times 1 plus 0.08. Use your parentheses nested there to the 60th power. You got about $595.94. The more time that it compounds, that's better for you because that means the interest is getting compound. Make more money. Okay? Suppose he did the continuous. Well, what is the continuous equation? Let's see what that is here. Continuous was A equals P times ERT. So A amount equals P times E to the RT. So principal is 400 times E to the rate of 0.08 times 5 years. So 400 times E to the 0.08 times 5. Make sure you have that all up there. 596.72. All right. So all these financial equations using to solve. All right. Another one, to find the annual percentage yield. So to find your annual percentage rate, you want to take 1 plus the rate over K to the K power, and then you want to subtract 1 from it. So let me just get that up there so I can see it. All right. So 1 plus, so suppose you invest 1,500 at 6.25 annual interest compounded quarterly. What is the equivalent APY? So we're going to take 1 plus the rate, 0.0625 over compounded quarterly would be 4. Okay. And then we want to take all of that to the 4th power. So we're going to go 0.0625 divided by 4. I'm going to add 1 to that, and I'm going to take that to the 4th power. Gives me 1.0639. But then if you remember, if you subtract 1 from the formula, so just take minus 1 on your calc, 0.0639, so about 6.4% would be the annual interest rate to compute the annual percentage yield. Okay, future value, I is equal to R over K, N is equal to K times T, N is the number of payments, so there's future value and present value, so get those up here because I'm going to use them on the assignment. All right, So let's go through a couple of these together. Find the future value of accumulated in an annuity after investing all those things right there. So we've got future value equals big R, so 610 times 1 plus I. Now remember, to find I, you have to take R divided by K. So R is 0.065 divided by K is 12. So 0.0054. All to the N power. Well, N is K times T. So K times T, 12 times 25 is 300. Okay. And then we're going to go minus 1 on the top. All over I again, which is 0.0054. So when you do this, you want to do your top first. Okay. So we're going to go 1.0054 to the 300th power. And then we're going to subtract 1. And then I'm going to divide that by 0.0054. And then I'm going to take that times 610 out front. So that means $455,366.72 if you had a future value like that. Okay. So that means if you put 610 in and you got 6.5% interest for 25 years, compounding every month, that's how much money you'd have. All right. Willis is the financial officer of a private university with responsibility for managing an endowment. If he invests $1.5 million at an interest rate of 8% compounded quarterly, how long will it be until the account exceeds $3.75 million? Okay, so he wants to get to $3.75 million. He started with $1.5 million times 1 plus the rate 0.08 compounded quarterly, all to the 4t power. We're trying to figure out how long it's going to take. K is 4. 0.08 divided by 4 is 0.02, so that would be like 1.02. So we're going to divide by 1.5. So 3.75 divided by 1.5 is 2.5. And now we have 1.02 to the 4t. So I'm going to take the natural log of both sides and then divide natural log of 1.02. And then remember, that would swing that 4t down in front. So we can go natural log 2.5 divided by natural log 1.02. And then we would want to divide that by 4 to get our time. Divided by 4, about 11.56 years until he got to 3.75 million. So using those logs to do those financial equations.